Okay, so looking at our warm-up here, stuff we did yesterday, solving these proportions. Now, before we actually work this out, I want to show you, okay, so in proportions, I mean, everything's proportional. So let's think about this. How does 16 relate to 32? What is 16 to 32?
Half of it.
It's half of it, right? So since this number is half of this number right here is going to be half of this. What's half of 40?
20.
It's 20. It's going to be 20, okay? But let's go ahead and work it out like we did yesterday. So let's cross multiply. 40 times 16 is what? Is 640. My equal sign, multiply this way. What's 32 times z? 32z. Okay, then to solve for z, divide both sides by 32. And so 640 divided by 32 is what? Is 20, just like I said. 16 is half of 32. 20 is half of 40. Okay, number 2, let's cross multiply. 2c times 20 is what?
40.
It's 40c. And then 30 times 12 is what?
360.
It's 360. Divide both sides by 40. So that gets c by itself. And 360 divided by 40 is what? Is 9. Okay, on or the next one. So what's 5 times 24? What's 5 times 24? Is 120 equals. Okay, we'll multiply this way. Now remember when we multiply here, we have 2k and 1. So there's two pieces. So the 8 has to get distributed to both of those. Okay, good. So it's 16k plus 8. The 16k comes from 8 times 2k. The 8 comes from 8 times 1. All right, and then from there, we're just solving for k, so minus 8 on both sides. 112 equals 16k. Divide both sides by 16. And so k equals 7. All right, and then on this last one, 18 times 20 is what? Is 360 equals, what's 9 times 1 plus 3w?
9 plus 27.
Good. 9 plus 27w. Right, because 9 times 1 is 9, and then 9 times 3w is 27w. All right, I'm going to subtract 9 on both sides. This zeroes out. This leaves 351 equal to 27w. Divide both sides by 27. And it gives you a 13. Okay. So today we're going to talk about ratios in similar polygons. So remember, ratio is a comparison of two numbers, and we're going to be using proportions today also. A proportion is a comparison of two ratios. Okay, so a couple things I want to define before we get into what we're going to look at. So the first thing is similar polygons. Okay, first thing in similar polygons, these are two polygons that have the same shape, okay, but they have different size. Same shape, but different size. So it's like, on your computer, like if you're, like, let's say you've got a picture of something that you're trying to enlarge on your computer. And you grab on it and you, say it's a picture of a person. And if you're trying to enlarge a picture of a person, do you ever want to just drag it all the way sideways? Will the person look good if you just take that and drag it sideways?
No.
Like if you try to stretch it like that? No, because then their face is going to be all messed up. Well, what if you take it and just drag it straight down? Is that going to look good either? No. So what you want to do is, do you know the trick? Like when you click on something, if you'll push the shift button on your computer, as you start to do that, it'll keep everything proportional. So as you grab that and you start to do it, push shift and then drag it. it'll make the length and width grow by the same proportion, and it'll make it look right. Okay? So that's what similar polygons is like that. It's like taking a picture on the computer, enlarging it, comparing the first one to the last one. They're the same shape, everything's the same, it's just that it's a different size. Okay, another thing in similar polygons is that it has congruent angles, okay, and proportional sides. In similar polygons, all the angles are going to be congruent. They're exactly the same. The sides are not going to be the same, like we said, but they are going to be proportional. And I'll show you what that means better in a little bit. Okay, the second thing is scale factor. Okay, scale factor is a number multiplied to scale, to scale a figure bigger or smaller. So a scale factor is a number multiplied to scale a figure bigger or smaller. Okay, so on this first part here, it says if triangle ABC is, and it's got this little symbol right here, this is the tilde symbol. So when you see that little symbol right there, that means that they are similar. When you see that little symbol right there, it means that the two figures are similar to each other. So if they're similar, then all of this stuff right here applies. The angles are congruent, the sides are proportional. So this is telling us that triangle ABC is similar to triangle XYZ. So we're going to list all the congruent angles and all the proportional sides. Okay, so let's start off with the angles. So angle A. All right, so angle A matches up to what angle on the other triangle? To angle X. And these are going to be congruent since these are similar. So angle A is congruent to angle X. Okay, angle B is congruent to what angle? Okay, so angle B is congruent to angle Y. And then angle C is congruent to what? To angle Z. Now, the way we got this was by looking at these and basically comparing them. And that's fine, but there's an even better way than that. It's just looking at this statement right here. Since A is the first letter and X is the first letter, those two sides are going to be the corresponding angles. So A goes to X. See, B is the middle, Y is the middle. So B and Y go together. And then C is the last one, Z is the last one, so C and Z go together. So sometimes when you look at the picture, it may be a little bit confusing. But if you just look at this statement, a lot of times that'll clear it up right away because the order here matters. Okay, so it helps us to figure out what goes with what. All right, now let's talk about the corresponding sides that are proportional. Okay, so let's go with BC first. Okay, so side BC. So side BC on the smaller triangle on the left matches up to what side or corresponds to what side on the other triangle? To the YZ, okay? So BC, this side is to this side. So BC is to YZ as, okay, let's go ahead and go with BA next. So side BA here matches up to what side on the other triangle? To YX. Okay. As, and then the final one here is going to be CA. So CA on this triangle matches up to which side on the other triangle? To ZX. Okay. So what we're saying is that BC relates to YZ in the same way that BA relates to X or YX. And that BA relates to YX in the same way that CA relates to ZX. So in similar figures, similar polygons, this is always going to be the truth. The sides are proportional to each other. And we're going to use that idea to help us find out whether things are similar or not, and we're going to use it to help find missing sides. Okay, so what I want to do on this one is I want to know, are those two quadrilaterals similar to each other? And so what I'm going to do is this, is I'm going to use the idea we just talked about. So the side that's 9, what side matches up to that on the other one? The side that's 6. So the side that is 9 relates to the side that's 6 in the same way that the side that is 12 relates to, which side does that match up to? To 8. Okay? In the same way that the side that's 18 relates to the 12, in the same way that the 15 relates to the what? To the 10. Now, what I want to know is, I put equal signs here. I really shouldn't have, because I don't know if these are equal or not. So that's what we're going to check and see. Is 9/6 equal to 12/8? And I guess there's a lot of ways to do that. The easiest way is, let's just get a decimal on this. So just type that in your calculator. 9 divided by 6. Let's see what that is as a decimal. Is 1.5. Okay, what's 12 divided by 8 as a decimal? 1.5. What's 18 divided by 12? Is 1.5. And then 15 divided by 10 is 1.5. Okay, so actually this is good. All of those are equal. So since all of those ratios are equal to each other, that tells me that these two are similar to each other. Okay? These two are similar to each other because of what we saw right here. Okay. So I want to do the same thing here. I want to know, is this triangle similar to this triangle? So let's match sides up here. So the 13 is going to match up to what side on the other one? To the 39. Okay. And then the 10 is going to match up to what? To the 30. And then the 14 is going to match up to the what? 42. Okay, so let's type that in our calculator and see if all those ratios are equal, to see if this is proportional. So what's 13 divided by 39? Is what? 0.33? Is that right? What's 10 divided by 30 as a decimal? 0.33. What's 14 divided by 42? Is 0.33. So are all of those equal? Yep, that's equal, that's equal. That tells me that these are similar. Okay, now one other thing I want to talk about here real quick is what we talked about up here about the scale factor. It's a number multiplied to scale it bigger or smaller. So on this one, going from this one to this one, did it scale bigger or smaller? It scaled bigger. So it's the number you multiply by. So let's think about this. From 13 to 39, or, well, yeah, that'll work. So from 13 to 39, what do you have to multiply 13 by to get 39? Is exactly 3. 13 times 3 is 39. Okay? 10 times what gives you 30? Times 3. Okay, 14 times what gives you 42? Times 3. So notice, and I mean, it's the way it's going to be because this is similar, but that right there tells me that's the scale factor in this problem. The scale factor is 3 on this one, whenever you're going from the smaller one to the bigger one. It's the number you multiply by. Okay? We're multiplying by 3 on that one. Okay, let's see if these two triangles are similar. Now the way I'm going to do it is this to match it up. Okay, what's the biggest number on this triangle? Is the 32, okay? So 32, what's the biggest number on this one? Is the 16. So 32 is to 16. Okay, what's the second biggest number on this one? It's 27. What's the second biggest number on the other one? It's 12. And then the smallest number on that first one, 24, and the smallest number on the second one is 9. Okay, so let's type those in and see what we get as a decimal. What's 32 divided by 16? It's 2. What is 27 divided by 12? 2.65? Oh, 2.25. And then what's 24 divided by 9? 2.66. Okay, are all of those equal? No. These are not equal. So what that tells me is that this side does not relate to this side in the same way that this side relates to this side. So what that tells me, as this was being scaled down, to go from 32 to 16, it scaled down by half, okay, by 2. And the 27 to the 12 did not, scale by 2 or 1/2. It scaled by this. So each side was scaled by a different number. That tells me that these are not similar. This side does not relate to this side in the same way that this one relates to this one. And, that's all that has to happen. It just has to be one that's not the same. All of these are different. Okay, on the back. So let's think about this. First of all, it tells us that these are similar. So on this one, we're not asking are they similar or not. They're telling us that they already are. So let's think about this from 32 to 16. How do you get from 32 to 16? Divide by 2, or if you think about multiplying, it's multiplying by 1/2. So that tells me in this problem, from here to here, the scale factor is 1/2. Right? 16 is half of 32. So everything on this side, all the side lengths are going to be half of whatever they are matching up to over here. So this side is going to be half of this side, right? So how long is this side going to be if it's half of this? It's going to be 19. Half of 38 is 19. Now over here I'm looking for x. This side, 13, is half of whatever this is. Okay, good. So 13 is half of what number? It's half of 26. Okay. Now, down here at the bottom, we're going to use kind of the combination of the idea of scale factor and the proportions that we were just doing, which actually it's all the same thing, really. It's just looking at it a little bit different. So on this first triangle, this side that is x, that has, that's x in length, what side does that match up to on the other triangle? The 9, okay? So, and it tells us that these are similar, so I can use proportions here. So x is to 9 as... Okay, let's go with the 8 here. What does this 8 match up to? To the 12. So the x matches up to the 9 as the 8 matches up to the 12. And so what I'm going to do now is, see, I set up a proportion like I did on the other side. Instead of having all numbers here, now I've got a variable. So I'm going to use this idea to solve for the x. So I'm going to cross multiply just like we did yesterday. What's 9 times 8? Is 72. What's x times 12? 12x. Divide both sides by 12. And what does x equal?
6.
Good. X equals 6. Okay, next one on this number 2. Now, before we even work it out, we're going to work it out the same way. I just want you to think about this. Going from 10 to 5. What happens going from 10 to 5? Gets cut in half, right? So I know to find this x, it's just going to be this number cut in half. What's 4.5 cut in half? Is 2.25, okay? So I'm already saying I know the answer is going to be 2.25 as we go through here. But let's go ahead and work it out and just see that. The answer is going to be 2.25. All right, so the 4.5 matches up to what side on the other one? The x. And then the 10 is to the 5. So let's cross multiply. X times 10 is 10x. 4.5 times 5 is what? 22.5. Divide both sides by 10. And so 22.5 divided by 10 is 2.25. Just like I said right there. Okay. Number 3. The x plus 1 matches up to what side on the other one? To the 24. Okay, so this matches up to this. Now, am I going to use that 18 there? Okay, no, I'm not going to use that 18. Why am I not going to use that 18? Because I don't know how long that side is that matches up to it there. So I'm not going to use that 18, okay? What I'm going to use is this 12, because do I know the side that matches up to that on the other one?
Yes.
Yeah, it's 18. Okay, so the x plus 1 is to 24 as the 12 is to the 18. So let's cross multiply here. What's 24 times 12? It's 288. What is x plus 1 times 18? 18x plus 18. Exactly. Because the 18 times x is 18x, and the 18 times 1 is 18. Remember, there's two different terms here, separated by a plus or a minus. Alrighty. So we're going to subtract 18 on both sides. We get 270 equals 18x. Divided by 18. X equals what? X equals 15. All right, I want you to try number 4. Set it up to find the value of x, set it up, and then cross multiply and solve for x. Try that one. Okay, so this is the way I set it up. X plus 15 is to 18, as 40 is to 30. Okay, as you set up these proportions, the one thing you have to be careful of is this, is that, okay, since I put the x plus 15 on top down here, okay, right here, that the number, that's on the same triangle as the x plus 15, which in this case is the 40, has to be the top number over here also. So you got to be consistent in the way you set it up. There's a lot of different ways to set it up, but you just have to be consistent in the way you do it. So if you put this over this, then you have to put this over this. Okay, so let's work this out. What's 18 times 40? It's 720. Okay, then what is 30 times x plus 15? Good, 30x plus 450, because you've got to do the 30 times EX, that gives you 30X, and 30 times 15 is 450. All right, so we're going to subtract 450 from both sides because we're solving for X. I want to get the X by itself. So 270 equals 30X. Divide both sides by 30. And X should equal 9. Okay, real quick, let me help you get started on this assignment. So the first two, you're doing like what we did on the first few problems on our notes. All you're doing is saying if it's similar or not, okay? So like on number 1, you're going to put 6 is to 4 as, what else? 9 is to 6 as 10.5 is to 7. And what you're going to do is just see, are those ratios equal to each other? And you can just get the decimal to see if they're equal. If they're all equal, then those two figures are similar to each other. If they're not all equal, they're not similar. So that's what you're doing on 1 and 2. Now, starting on number 3 through the rest of the paper, you're going to be doing the same thing, basically. You're going to be finding the value of x. So on this number 3, there's the x. What side matches up to that on the other one?
13.
The 13. So on this one, you're going to say 13 is to x as, and here you have options. Because we have the 14 and 7, you could use that. You have the 12 and 6, you could use that. You could have the 26 and 13. Any of those are good. Because if you notice, they all relate to each other in the same way. How does 14 and 7 relate to each other?
Half.
It's half. How does 12 and 6 relate?
Half.
It's half of that. 13 is half of 26. So it's going to end up being that, they all relate to each other in the same way. So you can choose whatever you want. You could put the 14 over 7. You could put the 12 over 6. You could put the 26 over 13. It's all going to work out the same way. End up in the same number. And then from there, you're just going to cross multiply and solve for x. So basically, all the rest of the problems on this are going to be like that, where you're actually solving for x.